Hi, everybody. Welcome to another Duende Software live stream. I'm really excited about today's live stream. Our guest is going to be talking. Oh, it. Oh, I'm not muted. Okay, there's a weird thing here. Our guest is going to be talking about a very specific topic that I think everybody doing .NET will be interested in. But before we get to our guests and introduce them, let's do a little bit of housekeeping here at Duende. First of all, thank you for everyone joining here live on YouTube. If you're in the chat right now, let us know where you're joining us from. Use those flag emojis. Those are always fun. So put those in there. And be sure to ask any questions that you have. We'll kind of gather them up and present them to our guest somewhere during the presentation, but we typically save it for the end. Common question that a lot of people ask during these live streams: is this live stream being recorded? Yes, it is. So if you need to go pick up the kids, take the dog for a walk, hit the bathroom, because we all need that. You can pause it, you can leave, come back, even come back later. Be sure to like and subscribe, hit that notification bell, and you'll be notified when this live stream becomes available for later viewing as well. So, on that note, let's introduce our guest today. Tor, welcome. I can say a little bit about you right now.
Yep.
You're an independent software consultant based in Helsingborg, Sweden. But you have clients all over Europe. So, folks are definitely joining us from Europe. They should check out Tor's website. He has a focus on .NET, C Sharp, architecture, DDD, and CQRS. And most importantly for us here at Duende, web security and OpenID Connect. So Tor, thank you for joining us.
Thanks. I'm very happy to be here and looking forward to do this presentation with you at Duende. And I've been using your identity server for many, many years now. And it's always a fascinating topic to both teach and consult in and to learn about all the kind of inner details about authentication and OpenID Connect and how you build secure applications, because we see on a daily basis in the news how websites gets hacked, user databases get leaked, and data breaches. So, and in this talk, I want to set the fundamentals of how does authentication work under the hood in ASP.NET Core, because I feel that many people don't really understand exactly what is going on, what's a claims principle, what's an authentication ticket, and it's all kind of magic sometimes. So I hope today's presentation will bring some light around this topic.
Okay, great. Folks watching us live, remember the chat is available right now. I also see there's Duende staff members in there as well. So if you want to say hi to them, feel free to talk to them, ask them questions. But Tor, the stage is yours. I'll be here if you need me, but
Yes,
good luck.
thanks. So maybe I should start. Thanks for the introduction, Khalid. So my name is Nestenius. I'm from the south of Sweden. As he said, I'm a freelancer. I do teaching, workshops, and training in the areas of .NET, authentication, and security, and OpenID Connect and Duende Identity Server. I also blog frequently about authentication, .NET, and security on my blog at nestenius.se. So to start with, I want to kind of do this presentation around my sample application. So if we go back to Visual Studio, we have a simple application. Right now, it's really insecure. There's no authentication in place. We do have one secure page that we want to secure. I do have a login function, but it's not really working. I do have an option to view become the user details, and I will come back to that one later on. So I will be kind of working on this application, adding authentication step by step, and trying to explain what is going on under the hood as we go along. So the goal is to look at, you know, when we have an application, when we authenticate and when we log in, we can display the name of the user, for example. We know who the user is. And to do that in code, you might use your eraser page, and you would maybe use the use object to get the current identity, and then from that get the name of the user, and that is how you get the name of the user. But at the same time, who is that user? And that user is an object called ClaimsPrincipal. And for me, when I started, ClaimsPrincipal was a really weird name for type in .NET. But eventually you start figuring out, and it becomes natural to you. So the big question is, what is a claims principal? So this claims principal object is a pretty simple object. It basically is a container for a set of identities. So you might have one or more identities when you are authenticated to your application. So in code, a claims principal basically is just a list of claims identities. Okay, that makes sense. But then the question is, what is a claims identity? And a claims identity is another type in .NET. So it contains authentication type, is authenticated, and a set of claims. And in code, the kind of main data structure inside it, it is a list of claims. And then, of course, the question is, what is a claim and a list of claim? What does it mean? And in code, a claim is actually a fact about the current user. It might be the user's identity. It might be his email, his name, his roles, or country, or gender, or whatever. Some fact about the user. And this is the data you load from a database uh, and add to this claims identity that then goes back into the kind of claims principal object. So that's, really key. So the claims are the really key things. And if you use the Duendo Identity Server and OpenID Connect, or just use simple authentication in .NET, we all use claims, and all those claims together, that creates your identity in the system. So, but then, of course, okay, so we have seen that we can get the name of a user from a user object, and the user object is a thing of type claims principal. But then the question is, who sets it? Who creates that object? And to figure that out, we need to go down into the kind of internals of ASP.NET Core. So inside ASP.NET, we have a request pipeline. So when a request comes in from the outside, it goes to the web server, gestural in many cases. The web server will kind of transform the incoming request into an HTTP context object. And then that object travels through the request pipeline, through a set of middlewares. And those middlewares and depends on, or it all depends on your application. And it is you that configures this request pipeline and adds the necessary middlewares to build up your application. But eventually it reaches the kind of final destination. And in many cases, it is the MVC framework. That one will look at this object and then render the page. And then that rendered page becomes your response, and that response is placed back into the HTTP context object, and then it goes back through the request pipeline back to the web server, and then we'll transform it into an HTTP response. So this is how it works, in general, when a request comes into an ASP.NET Core application. So, but the one who creates it is typically the authentication middleware. This is a middleware you add to this request pipeline, and its job is to look at the incoming request, try to figure out who the user is, and eventually try to create a claims principal object and add it to the HTTP context object, and then pass it along to the page. So this is really key. This middleware module is the one who typically creates the user for you. And of course, the question is then, where does it get that information from about the user? Well, it all depends on how you configure it. The source of the user information might be a cookie, it might be an access token, it might be a certificate, or some other means for, for providing your application with the necessary credentials. So in our case, if you go back to my application, the first step is, of course, to add the authentication middleware. And of course, yes, if you don't add it, in many cases, ASP.NET Core will add it for you. But I really like to be explicit about my code and to have that, in my application. So in my case, I will services builder.services.add authentication. And then I will also want to add it to the request pipeline. And you always do that before authorization, because you need to know who is the user before you can decide if the user is allowed to do a specific operation. So this line, together with that authentication, adds this authentication middleware to the application. So with that in place, we don't need to run it because it basically will not do any change to the application so far. But then the question is, what is inside this authentication middleware? Because right now we haven't configured it, so it will basically do nothing. We need to configure it for it to do its job. And in our case, to configure it, your main job is to add one or more authentication handler to it. And for example, you can add the cookie handler by adding the add cookie statement like this. You can use the, if you're making an API that you want to protect, you add the JWT handler. And if you're, for example, using OpenID Connect with, for example, together with Duende Identity Server, you would use two handlers, one cookie handler and one OpenID Connect handler as the most common configuration. So these three configurations are the ones that you most of the time will be using, one of them. So in our case, in our application, we want to add the cookie handler because we're making a simple application today. We want to add the cookie handler to manage the authentication for us. So we will add the add cookie, and we will also set the login path, logout path, and access denied path as a configuration. So in my case, I will add this to my application. Just copy the code in here. And of course, I could run it, but nothing will really happen. Still will not, nothing will happen. So right now, it is like before. But we are one step, towards the goal of adding an understanding authentication in .NET. So with this handler in place, we need to, also go into what can I do with this middleware and these handlers. So the key thing to know here is that each handler only supports up to five different operations. There are basically five key operations you need to understand to be successfully with authentication in .NET. The first one is authenticate. And the authenticate operation is typically called by the framework, and it goes to the handler, and it basically looks at the incoming request, and it kind of answers the question, who are you? So the authenticate step in the cookie handler will look for a cookie. It will try to decode the cookie, and if it is valid, it will create the ClaimsPrincipal object and add it to the HTTP context object. So that's the role of authenticate. And the key here is that authenticate will be called on every request that passes through the authentication middleware. The next one is sign in. This is when you log into your application. You want to remember who is this user. And basically, when we use a cookie handler, you will basically set the authentication cookie. And we'll come back to that a bit later, how that looks and how that works under the hood. But sign in is about remembering the user and creating the cookie. And then, of course, if you can sign in, you often want to be able to sign out. And when you call the sign out operation on the cookie handler, the main job is to remove the authentication cookie from your browser. And then we have forbid. In this case, let's say you go to this application, you provide a cookie. We know okay, we know my Swedish here. So we know who the user is. So we have established that we have a user here, but in this case, the user is not allowed. Maybe it does not have the right credentials, it's missing some claims. So someone else further down this request pipeline, maybe the authorization service or your application says that, hey, you're not allowed to access this page. So they will call the forbid operation. And in the most common case, you will be redirected to the access denied page. And finally, we have a challenge operation. This will be typically be triggered when you make a request to our application, but you don't have any valid authentication cookie. We don't know who you are, and then you are denied and you are challenged. Basically asking the user to please go and authenticate and come back again. And when we use a cookie handler, for example, the most common case is that we will redirect you to the login page. So these are the 5 operations that an authentication handler can implement and support. And those operations you can call from your code, or they will be kind of triggered by other kind of middlewares in your application. So in our case, we have a secure page. We really want to make it protected. So to really make it simple in this case, I will add some code to ask if the current user is authenticated. And if it's not, we return a challenge back to the authentication middleware. If it's challenged, we will display the page. So in our case, we have, I can show the view first. We have a secure page here. This is my super secret page. And in my secure controller, I don't have any logic right now. So I will add this to this page. So basically, that means now that when I try to access this page, and if I'm not logged in, I will be challenged. And basically, it will redirect me to the login page. And where is it redirected to? Well, that is typically configured here when we added the cookie handler. This is the login path. So we will be redirected to this login page if we are challenged. So if we start the application and we are not logged in, and if we try to go to the secure page, a redirect will be made to the login page. So one step, towards the goal. The login does not work, so nothing will work. But at least we have secured this secure page from non-authenticated users. You must be authenticated, be logged in to access this secure page. So this is a really good step forward, but we're not there yet. We need to look at a few more things before we can get it all to work as we want. So what triggers this operation? So we can, if we want in code to trigger these operations, we have a few options to do that. We can either call the, for example, authenticate or challenge or sign in the user or forbid or similar. So we can call these extension methods that are kind of added to the HTTP context object. But I think many times people are a bit confused what happens when I do this operation. So what happens when I do a call to the challenge async method is that I will make a direct call to my authentication handler, and that one will, on the context object, create a redirect result, set that redirect so that later we can be redirected to the login page. So that is maybe pretty simple. And then you come back to my index page, and I can do some other things here. And then we have kind of set the response to be a redirect to the login page. So that's simple. The other approach we can do is to return, for example, a challenge result or sign-in result. So when we, from our action method, return a challenge, for example, when we do that, returning a challenge, what's that? What a challenge. So when we do that, there's actually a shortcut for returning a new challenge result. Okay, so instead of returning a view, we are returning a challenge result. So then the question is, what happens internally when we return this challenge result? So internally, so let's say we have a request comes in through a middleware, through a handler, through a request pipeline, and then will come to my action method. And inside this action method, we return a challenge result. Okay, so that means that this result goes back in a pipeline, and eventually it will kind of be passing through the authenticate middleware. It will detect that, hey, this is a result that I'm interested in. So I will call the challenge operation on the cookie handler and then set the redirect to the login page. So, and then that becomes a through to redirect response back to the browser. Okay, that's simple. But then, of course, will that challenge always redirect? Well, it all depends on the authentication handler that you have added. If you're using the cookie handler, then that would be a redirect. But if you're using, for example, building an API using the bearer handler, a challenge there will mean that you're returning a 4.1 unauthorized response instead. So the response from a challenge might vary depending on the handler you have added to your authentication middleware. So a common problem I see is this, that you have an action method, we call the challenge async, and then we do a redirect. And it shortly will redirect, but maybe not always what to expect. So in this case, we first do the call to the challenge async method. That means that we call the challenge on the handler. Okay, makes sense. We create a redirect to the login page. We set it on the HTTP context object. All is good. We go back to my application here. We do something here, and then we do a redirect. But we return a redirect. But returning that redirect will basically replace the previous redirect with a new redirect. So in this case, I think it's a pretty common gotcha, but you think you're doing a challenge to the login page, but you're actually not doing any value here, because the return redirect here will basically invalidate or just make this a non-operation. The challenge will not do anything useful here. So that's a common gotcha that I see, for example, on Stack Overflow. Next, we need to talk about schemes. It's also a really crucial concept to understand in ASP.NET Core. So, for example, let's say we have two handlers inside our authentication middleware. And when we, for example, do a challenge, okay, so we come here to the challenge, but then the question is, which handler should handle the challenge? Because you only want one of them to handle it, either the first one or the second one, not both. So how do we decide which one should do the challenge in this case? So in this case, we can configure the authentication middleware and configure which one should do which operation. And for example, when you use OpenID Connect, you typically want the OpenID Connect handler to manage the challenge operation while you use the cookie handler for all the rest. So you would, in your add authentication, add this kind of setting the kind of default scheme that you want to be called when for each one of those 5 operations. And yes, there are different ways to kind of define this schema mapping, but this is the kind of the most fundamental one, I would say. And of course, you can always challenge a specific scheme if you want to, but it's always good to have a default scheme set in code. And also, as you see here, you can name the handlers that you add to your application so we know which one to be used when. So that means that in our application, we can set the default scheme to be the cookie because we only use the cookie handler in this application. So we go back to the my application. I will just put that into here, setting this one. And in this case, it doesn't make any kind of big difference on the functionality of my application because we only have one authentication scheme. So, and if we were to run it, nothing special would be happening. It will be the same as before. We can't access the secure page. We are redirected to the login page, but this one is not really implemented yet. So that is the current state. But before we can continue, Khalid, do we have any questions from the audience that we should address before we continue?
We don't have any specific questions, but an interesting observation that we've seen in the live stream. I asked if people prefer MVC, Razor pages, or minimal APIs, and folks have said a mixture of all 3 of those things. But it's currently the examples you're showing are using ASP.NET Core MVC. The
Yes.
question I have for you, when you're talking about these 5 operations in terms of authentication, they're not just specific to MVC, right? They're specific
Yeah.
to ASP.NET Core and just
Yes.
work across all those other frameworks
Yes,
as well.
that is correct. It's all applicable to all of them, regardless of if you're using minimal APIs, Razor pages, or classic MVC. I'm pretty old guy, so I like the kind of classic approach. That is what I'm used to. I'm not so fancy at doing the minimal APIs yet, but of course, I see the benefits of minimal APIs performance. But I really think that when you're teaching authentication, you want to make it as clear as possible. And I think the minimal APIs hides a bit of magic as well. But it's also important that this authentication middleware is also applicable to if you're using, for example, gRPC or SignalR or other kind of transport mechanisms. So it's not just for web applications. So it's a general concept that works for almost every type of communication in ASP.NET Core.
Okay, awesome, awesome answer. On that note, just go ahead and continue, and I'll
Yes,
monitor the live chat. Again, folks, if you have any questions, leave it in the chat, and we'll ask Tor throughout the live stream. So thanks. Go
sounds
ahead,
good.
Tor. Yep.
Great. So, okay, we need to kind of fix our login page. We have right now a stub for it, but there's no logic. And the end goal is to all the sign-in operation. You want to be signed in so we can access this secure, really secure secret page. That's the kind of end goal here. So I do have in my application an empty action method for the login and for the kind of showing the login page and also for the kind of post back from the login form. And I do have a simple login model object that is in place that contains the username, password, and the return URL. So what do we do inside the login? So when we click on the login button, we need to, of course, validate the username password. Do they actually match what is in my database. But to keep it simple, we assume the user is valid, really, really secure, of course. Then we load all the claims for the given user from our database, basically creating a list of claims. And these claims can be anything you like. Subject is typically used when you use OpenID Connect, representing your unique user identifier. You can might have your name, email, role, and other claims. Any claims you like. Okay, so given the claims, the next thing we need to do is to create a claims identity. And the claims identity takes those claims. It includes the authentication type. And that one is a bit kind of, what is that? What is the authentication type? And basically, it is a string that contains some description of how did the user authenticate. And to the right in the table, we see some commonly used phrases as authentication type. But basically, it is a string. It must be set, because otherwise, if not set, you're not considered to be authenticated. But the exact value here is less important in this application. And we also specify what is the name of the name claim. That also helps when we want to get the name of the user. We can also specify the name of the role claim. So in case you have some other kind of name for the roles, you might specify that as well. But just having an identity is not enough. We also need to create a claims principal. So we see we have the claims, we put the claims into a claims identity, and then we take the claims identity and place it inside a claims principal. So the principal here, that is your identity. But just creating the identity is not enough. We need to do something with it as well. So next, we can optionally also add some authentication properties. And the authentication properties are general additional metadata you can set to provide extra values for the authentication handler. You might also want to add some extra, data like from what IP address did the user log in from, maybe some secret keys or some computer name, whatever you like, some extra metadata. And those two, together with the name of the handler that you do the sign-in, we pass to the sign-in async method. So the sign-in async method will take your principal and your optional properties and send it to your cookie handler, and then it will kind of create the cookie based on that. So that means that in my application, I will add this code to my login handler code. So in my user controller, I do have an empty login page here. And of course, all of this code will be available to you afterwards. And I will give you a link to my GitHub repository with my presentation and this code. So you can always go back and look at it on your own. But basically, when I click on the login button, I'll come in here, I create my list of claims, create the identity, create the principal, create some authentication properties, and then I call the sign-in async method. And after that, I might do a redirect. This one is not really necessary, but just to keep it simple. And now we can actually run the application one more time. And this time, we should see that if I go to the secure page, I'll come here to the login page. I can actually go back here and add a small breakpoint just to show you that when I click on the login button, I come in here, I create the identity, set the principal, create some properties, I'd call the sign in, and then redirect to the home page. So now we see that we are authenticated, we are signed in to this application. And if I now click on the hello Bob here, I can see details about the current user. We can see that we authenticated using password. That is basically what I kind of defined here when I define the authentication type. And because we specified the authentication type, we are also considered authenticated. And we also know the name of the user. The name is Bob, and it knows which claim to look for because we specified the name claim here. And that is what we can actually see here. And then I list all the claims that I have about the current user, and those should match these ones. And then I can also see the authentication properties, and that is this one here. We also see that the authentication handler, the cookie handler, will add some extra authentication properties, and that kind of defines when did the user authenticate and when does the information inside the cookie expire. So that is about 2 weeks default. So that is good. And when we now are authenticated, we can actually access the secure page. And only if you are signed in, we can access this super secret page. Awesome. So once that's done, so we can continue. Next, we need to maybe go a bit deeper and look what actually happens internally when we call sign in async. So when we do that, we saw before in my code, we take my claims principal object, we take the authentication properties, we take those two objects, we place them inside a new construct called the authentication ticket. And the authentication ticket is basically a container that contains the name of the scheme, the name of the handler, basically, the claims principal, and the authentication properties. So all of those three items are placed inside this kind of ticket object. Then that ticket is encrypted using really secure encryption. And then a cookie is created and sent to the browser. And optionally, it might do a redirect to some page of your choosing if you want to. So basically, that is what happens when we call the sign in. We create a ticket, we encrypt the ticket, and that encrypted ticket goes into the cookie itself. So when we sign in the user, we create a cookie and store it in the browser. Basically, we do a set cookie operation. We have an ASP.NET Core.cookie cookie name, and then some random encrypted data and some other kind of security attributes that we also add to this cookie. But the question is always, what is inside this cookie? Is it just a random string of text, or are there actually some content inside it? But we also said, if you go back here, we actually do encrypt it using a very secure encryption. So how can we look what is inside this cookie? Well, luckily for us, there's an extension point. We can actually add our own really secure encryption. You replace the secure built-in encryption functionality with our own custom encryption. And this one is really, really secure. Basically, when we protect the authentication ticket, we just return it. And when we want to decrypt it, we just pass it through. We're basically creating a transparent encryption handler. And we can actually specify this one in the add cookie authentication handler. So we can actually go back to my main application. I just copy my super secrets, super kind of secure encryption logic, and also go up to my cookie handler here and specify I want to secure my authentication ticket with my really secure encryption logic. So now it gets interesting. So if we run this application, we go to the login page, we sign in as a user, and remove that breakpoint. We just continue. We can go to the browser, and we can see that we do have our authentication. Let's see if we can zoom in a bit. We do have our authentication cookie here. But still, this cookie is really kind of just random, stuff. So how and what can how can we look inside this kind of random string? But luckily for us, that string is currently just base 64 encoded. So we can basically go to a page and decode it. And of course, I do have Fiddler running, so I'll go back and do it one more time. I place it in here, I decode it, and as a result, we see that we can actually see the claims and authentication properties I added before. We are using here some binary serialization. We are not using XML or JSON. Instead, we have some binary serialization format that is kind of specific to the cookies. But still, it just shows that inside the authentication cookie, all our claims and authentication properties are stored together in one unit. And I think that is really a key thing to understand, that what goes inside your authentication cookie by default, that is your entire claims principal object. And that object and that is then sent to the backend and then decrypted and decoded and transformed into a claims principal object on every incoming request. So really, I hope that shows that what is stored inside the cookie, um, and of course, by default, it's really stored in a secure way using an encryption key. But with this custom encryptor, we can actually peek inside, and I really like, as a developer, to be able to look under the hood of things to really understand what is inside the cookie, and how does it work. Next, let's look at sign out. So when we want to sign out, we want to be able to click on log out button. That will basically call sign out async. We might, if you want to, specify the name of the handler who should handle it, and we can, in our case, it is the cookie handler. That method call will call the sign out operation on the cookie handler, and that one will basically remove the cookie in the browser. And to do that, it basically sets the cookie again, but this time with an expire time in the past. So that one deletes the authentication cookie from a browser, and you're signed out. So basically, we go back to my application and we add this logic to it to also implement the sign out. So we go to the user controller here. We go down here. We will send out async. And if we run the application one more time, we can log in as a user. We can see all the details. And if I click on log out, we see that we are signed out. Okay, we don't get any redirect. I will come back to that thing. But if I reload the page, we are actually signed out. So basically, we can now sign in, we can sign out, and if I go back and reload the page, we are signed out. But we also see that we did not get any good, nice redirection here. So when I click on logout, we're not really redirected here. So let's try to address that next. So the problem here is that we specified in the add cookie handler the logout path. So basically, you would think that the logout path is, where do I want to go after sign out? As a beginner, you would assume that is the purpose of it. So when you call sign out async, it does not really work, because we do remove the cookie, but we don't redirect. We just get the 200 OK back from the application. So something is not really working here, because obviously we would believe that when I do a sign out, I should be able to jump to the logout path. I mean, that is what the logout path is there for. I mean, that is the purpose, you would think. So when and then, it doesn't really work. You go to Stack Overflow, you Google, you find that some people are using the return URL in the query string. Maybe I can use that for something. So we go back and we try to add that to our application. So we go back here. We go back to I do have a partial view here. I can try to add that. So basically, I add the return URL here because we are seeing that on Stack Overflow, people are using that to specify where to go to after sign out. We try again, we run our application and we log in and then we log out. But this does still not work. That's odd. Why does this not work? Because we have specified in my code the logout path and we want to go here after sign out. So here's something weird going on. So the thing here is that just adding the return URL up here will not make a difference to the end result. We delete the cookies, that's good, but we are not doing a redirect. So we do some more Googling, some more AI, ChatGPT asking, and eventually we find the problem. And I think that the most difficult thing is, what's the purpose of the logout path? And it's not where to redirect after sign out. It has a different purpose. This is a security feature that says that if the path here matches this path, then it will use this path for the redirect. So basically, we need to change the logout path to specify what's the URL to my logout, action method, user/logout in this case. And if we do that, then we will do a proper redirect to the logged out path that is specified up here. So this is one of the biggest kind of surprises for me that I personally struggled with for some time to really understand what is really going on here. It doesn't really make sense. And of course, naming is hard. But so basically, we need to change this one to log out. And if we do that, we start the application, we log in, and then when we log out, we are redirected to a logged out page. And of course, how we do this redirect, doing it in the query string here, is one option. You don't need to do that. There's a few other options, and that is to do user authentication properties and specify the redirect URI. You can also do a local redirect after you have signed out more explicitly like this. So there's many options, but still, I really think that this logout path, the purpose of this one, is a bit really hard to really understand when you're getting into authentication in .NET. Khalid, do you have any questions so far? Or
We actually do have a few questions.
yeah?
A big one that somebody asked is when you were describing what goes into the claims versus what goes into authentication properties, like how do you decide where to put that kind of data? Like, what's your thought process there?
For personally, I see that authentication properties are they have two purposes. It's one, it's can provide extra data and information to the authentication handler, like the redirect UI in this example. That's something that is kind of used by the authentication handler. Yes, it's stored inside the cookie, and we can see that when we looked inside here, we could see I think the redirect. If we zoom in here, you can see the redirect is stored inside the cookie. So, but that one is mainly used when you call the sign in or sign out and where to go to after that. That one has no really key purpose. The other way thing is that this is additional data that you can keep about the user. It's not part of the claims, the principal, the real identity, but it's kind of metadata, extra data you want to kind of keep around because it's related to the user. Maybe it is kind of preferred country or language or some of the default settings that maybe you don't want to put inside the claims principal.
Hmm.
So I really kind of try to follow the kind of separation of concerns here, put stuff about the user, the identity inside the claims principal, and extra metadata um, outside, and put that inside the authentication properties.
Hmm.
The second thing with authentication properties, if I'm not mistaken, that can also propagate when you're using OpenID Connect. So you can remember those things when you come back after you have signed in to Identity Server. But that is a different kind of topic that is beyond the scope of today. I did actually do a blog post about that thing. I can actually quickly find it. And that is when you talk about state and nonce. And I think, if I'm not really if I remember correctly, there is those authentication properties can actually be stored and passed along to the to the to identity server and then passed back into the state parameter. You can find on my blog this blog post if you want to know more about that. I
Hmm.
can also paste the link into the chat. Um,
Yep.
and
That was a really good answer. Folks, check out Tor's blog. There's a lot of great content there. Um, Another question. This is likely your dry Swedish humor didn't come across properly, but somebody asked, I think Mraz asked this, can we trust the default data protector offered by the ASP.NET Core team, or is it advised to create our own? So
that
go.
is a really, really good question. I could do another webinar about that in the future, but it's the data protection API is really a big topic of its own. And you should use the built-in one because I don't see any reason why you should automate your own. First of all, I really would say it is secure, and you have a lot of configuration options where to store that encryption key. But it's really a key service that you need to understand as well, and configure properly, because I see so many times on Stack Overflow and others that if you don't configure it properly, you will, for example, when you redeploy, your cookies will no longer be valid, so everybody's signed out. So it needs some thought and care how you configure it, but you should use the built-in one, and you should be really configure it for production use. Um, and feel free to get back to me afterwards if you have any questions about data protection. But it's really a key service. It is secure, highly recommended. I don't know what your kind of recommendations, Khalid. Do you agree with me or?
Oh yeah, I mean, it's the number one issue we see here at Duende in terms of customer support. ASP.NET Core is set up to work with data protection implicitly, but in a production environment, you need to be a little bit more explicit about your application name, where data protection keys are stored. So, if folks are interested in that, Duende's documentation actually has a great troubleshooting guide and recommendations around data protection, just so you don't get caught off guard once you go from development to production and all of a sudden nothing works like it should. So, 100% agree with you, Tor. It's really one of those things that um, it's really easy to miss, but can like take hours off of your life trying to
Yes,
debug. So,
I
uh,
agree. And also, if you go back to my blog post, you will also find a few posts about the data protection API, and also how where do you store the key, I made one blog post about how you can store it in Azure Key Vault, for example, just for learning experience. I also have a data protection API keyring debugger tool that I created just to be able to play with it and understand how it actually works and behaves under the hood. But it's really a big topic. We could spend half an hour talking about the data protection API easily. So that's beyond the scope of today. Any other question?
Not a question, but I did find a comment here. I'm trying to find it very quick. Uh, a viewer said, I really like this idea of explaining each action of auth step by step. I wish tutorials made in the .NET space are more like this. So, Tor,
Yes.
you're doing a great job so far.
Oh,
Uh,
thanks. Thanks.
and on that note, I'll let you get back if there's any more.
Yes, we have some
And
more things.
then,
So,
yeah.
sounds good. So let's get back on track here. We find the log out, that part is done. So that's great. Perfect. We are done here. So, and of course, when you want to sign out, you can always do use authentication properties if you don't want to use a query string. And you can also do a local redirect, for example, after you call sign out, or you return a sign out, result. That was also an option. But we have another kind of question. Are we really signed out? And this is also a key thing that I feel that many people miss. That, for example, let's say what happens if a hacker steals your authentication cookie? What can go wrong here? So let's play with that. So we go back to my application. We can find my mouse. Uh, Here we log into my application, and then I open, for example, Firefox. So I have them side by side here. And of course, if I just copy the URL to the Firefox, I'm not logged in, of course. But what happens if I now go and copy the cookie from Chrome to Firefox on the left? So I can go here, I can just copy the name, I copy the value, and then I just reload the page. We should see that we are logged in, but apparently not. Let's try it one more time. It was easy to get to set the correct names. Yes. So just by copying the cookie from Chrome to Firefox, I can resume being Bob without having to sign in. So that's a problem. And I can access the secure page on both sides. Okay. But if I now sign out from Chrome, I'm still logged in on in Firefox. And that is because the the cookie is the key. It's like the hotel key at an hotel. If you lose your key, it's still valid to be able to access your hotel room, for example. And the same thing here. Your cookie is the key to your application as you. And if someone steals that cookie, even if you sign out, that cookie is still valid. And we can see that because that cookie has a built-in default lifetime of about 2 weeks, as you see here. So if a hacker could continue using this application for up to 2 weeks after you have signed out. And you can't do anything about it, more or less, by default. So out of the box, .NET makes an easy job to make it appears to work. But is it really secure? And you need to start thinking about, okay, how do we invalidate the cookie after you have signed out? And that's a tricky question. And exactly how to do that is maybe beyond the scope of today's talk. But once again, I do have a blog post. I will ask the Khalid to post it in the chat. And I will also kind of include in the material afterwards that will be placed on GitHub. But anyway, in the kind of big idea, how to solve this thing is to use a cookie session store. And basically, what you want to do here is to, instead of storing your entire claims principal inside the cookie, you store it in a backend database or backend in memory or some storage on the backend. So when you sign in, you take your authentication ticket, you store it in some database here, and then as a result, you get just a grid, a key, and that key is the thing that you store inside the cookie. So later on, when you then sign out, you just delete your session here. And that means that even if the cookie is stolen, the hacker can't access the site after you have signed out. And I think this is actually what you need to do to really make this experience, properly secured. And the nice thing is that ASP.NET Core has built-in support for adding this kind of storage. There's an interface to do that, so it's not really that expensive or that difficult to do. And a few other benefits by doing that is that you can implement additional functionality, like that you might see on Google, for example, where are you signed in? You can actually go in and sign out specific devices, so you can get additional insights and also better user experience by allowing the user to see where am I signed in. I can sign in, sign out all. I might also want to have an emergency sign out. If we are hacked, you can actually sign out all the users right now just by deleting this database. But the exact details about this is a bit beyond the scope of today's webinar, so I recommend that you go back to my blog post to talk about that. And finally, another thing that I really think people don't think about, and that is what happens if we have a lot of claims, a lot of claim data. So let's see what happens in our application. So if we go back to my demo application here, I go in and go to my user controller. I go up here where I create the claims. So basically, I create one gigantic claim here to just represent a lot of data about this current user. So what happens here now might actually surprise you. So let's see what happens. So we start it and we can sign in and things will work just fine as usual. No problems. We can see the details. We see that we have one big claim here and we can, if we want to scroll sideways, it's really, really long. So that's, we can see it here. I can access the secure page. But the surprise for many can be that if you go and look at the cookies, we see that we actually have multiple cookies. I should try to expand this a little bit. Yes. So the thing is that the cookie can only be about 4 kilobytes in size. And because my encrypted claims principal authentication ticket that is stored inside the cookie is larger than 4 kilobytes, then ASP.NET Core will, by itself, create multiple cookies, and this is going to be supported by default. So my gigantic authentication ticket is now spread over 4 different cookies, or 5, because the first one is just says that how many cookies do I consist of. So that can be in some cases maybe some performance problem, because this means that you're actually sending 16 kilobytes of cookie data on every request to the backend on each request. And that might be a bit performance overhead. And yes, there's a way to get around it. If you use HTTP2, maybe you can get some, there's some header compression there. But basically, when for each request, all of those cookies will be included. And how you solve this is also what I just explained in my blog post that I showed earlier about cookies on diet. And when you do that, use this kind of backend database, then that large cookie or that large authentication ticket will be stored in a backend component. And even if your authentication ticket is big, your cookie size will be just about 200 bytes in size, and that is much, much smaller and more performant. So putting your cookies on a diet and store it in a backend storage will make your cookie and your application more secure. And I really think that's good practice. I don't know, Khalid, if you have any thoughts about storing the cookies in a backend component.
Yeah, actually at Duende, we have a server-side sessions component that folks can check out. So that is something we typically recommend. There's also a third-party identity provider. I won't say their name, but they rhyme with Nissan Sentra. And that's a common issue that we see with our customers federating with that identity provider because those cookies can get very large because roles are kind of like expanded, namespaces are weird XML strings that maybe are larger than people expect. So yeah, uh, really keep track of your cookie size. Again, in our documentation, we have a great troubleshooting guide to kind of work around these cookie size limitations. So definitely check that out. I will also say, maybe something you didn't hit on, Tor, but is still kind of important. Cookie size limits are a browser thing, but they can also be a server thing. So your server, even though your cookie might be within the limits of what the browser expects, your server may reject a cookie if you have particular settings that limit cookie size as well on the server. So if you're running into cookie size issues, especially in ASP.NET, you actually might get a bad request exception if your server is set up a certain way. So keep that in mind. It's both a client issue and a server issue when you're dealing with cookie size. So
Yes. And I also think that if you have a proxy in front of you, like a load balancer or some other kind of proxy in between, it can also reject too large cookies or too large headers. So be aware about that. And I think also, especially if you use IIS, for example, I think it also has some weird limitations about cookie sizes. So watch out. Small cookies are your friend. So put them on a diet and store them in a backend component, I would say is a best practice, I would say.
Tor, but I love cookies. Why are you doing this
Yeah,
to
I know.
me?
I know. Yeah. You have
So on
to
that,
think about the calories. You want to have the quality calories and not the kind of bad ones. Factory calories. You want unbaked cookies
I
with
know.
baked with love and quality. Those cookies are still good to eat. So I would say.
Yeah.
So just to wrap it up here, just to kind of summarize, we do have this request pipeline in ASP.NET Core. We have the authentication middleware. That's the key part that is in charge of creating and establishing who is the user. And inside that one, what we did today is adding the cookie handler. You need to use a different handler for your scenario if you're making an API or using OpenID Connect. And inside those handlers, all those handlers support 5 key operations. Authenticate, that is to try to figure out who are you and to create the claims principal object. Have a challenge, asking the user to sign in. Forbid, deny access. You have the sign in and sign out. Those are the 5 key operations. You need to understand what they do for a successful authentication implementation. And when a request comes in, you have the HTTP context. And when you authenticate, call the authentication method, you try to identify the user. And maybe look at the cookies or certificate or some token or some other way. And from that, trying to create the claims principal object and add it to the HTTP context object. and that is then passed to your application, and then you can display that information on the page or make authorization decisions. Are you allowed to access this specific data or resource or specific page? So, time for questions. I will, end of the day, after this webinar, upload this presentation and the code to my GitHub repository. And feel free to look at my blog, because I have a lot of blog posts about authentication, about the internals of data protection, OpenID Connect, and security in general. And feel free to watch out to explore my training and workshops that I do from time to time. So back to you, Khalid. Do we have some questions or or not?
Again, to echo what the chat's been saying, I think you've done such a great job of going step by step that there are actually no final questions, I think you answered all of them throughout the live stream. So credit goes to you. I also want to thank the chat as well for kind of being engaged and asking these kind of questions throughout the live stream. So thank you to them as well. On that note, folks, check out Tor's work. If you need a workshop, if you need mentoring, if you need freelance software development, Tor's your guy. We recommend him. So on that note, again, I'm going to do the YouTube thing here. If you want more information about Duende and the products that we have, go ahead and visit duendesoftware.com. Follow us on all the socials. I don't know what they all are, but you kids know, you know what it is. If you want to be recommended for XML or anything else, follow us on LinkedIn. I think we can do that for you. Don't hold me to it. Martin can do that. Other than that, again, we're on YouTube. Be sure to like, subscribe, hit that notification bell. If you want more content like this, we'll bring it to you. So on that note, thank you folks for watching. And again, thank you, Tor. Excellent presentation. We enjoyed it. We